In my free pet bottle filament maker video number 3, many people are interested in doing a similar project for themselves. Because I think biggest limitation of the creativity for 3D printing is the filament expenses. And most people would agree with me. Therefore, I received a lot of comments and questions about the building steps. I will try to give an answer to these questions in this video. I will put a link to that video in the descriptions, and I am leaving a card right in the corner for that video if you are interested. I tried to answer all of your questions and remarks as best as I can, and try to leave no unanswered questions, both in YouTube and in Reddit. But there were also additional requests about another video which people were asking for visual answers for their specific problems. I think documenting this collaborative know-how would benefit others as well. This video is about the tips and tricks which was not covered in the previous video. And also I will try to answer questions which others might also have in their builds if they try to build one of them for themselves. This video might be longer than the other videos, so if you are not interested to watch the entire video, I will make chapters and you can click the one you are interested in and watch those instead. First, I would like to talk about the end material density and also feed rates. When you look from outside, it looks very smooth and transparent filament. But when you look closely to the cross section of the filament, it's not 100% solid. It looks more like a tube. Since slicing softwares are designed to work on standard materials, to compensate it, you need to adjust the material flow rate in your favorite slicing software. PET has similar characteristics to PETG, so all of the modifications that I will be talking about will be related to changes to PETG filament profile on Jura. And first you need to select the PETG profiling from the material selection menu, and after activating all of the settings in the software, you then need to go to the flow rate setting. I set the flow rate to 150% and it prints just fine. Let's talk about which type of plastic bottles that can be used. The truth is, it doesn't matter. You can use any type of PET bottle you want. What you would want is having enough of the same type of bottle for one print, because different types of bottles usually have different characteristics like color and thickness. Although it doesn't really matter, I mostly use two types of bottles mostly. I like cola bottles because they are easy to work with and I consume one bottle every week, so I have continuous supply. Second type of bottle is the oil bottles, because usually they have a lot of material in them. But make sure to clean them properly, because any material residue will affect the print quality significantly. You can easily learn type of the bottle just by checking the plastic recycle triangle. If it says 1 in the triangle, it means that the bottle made out of the PET. You can usually find this information on the sticker. If you cannot find the information on the bottle sticker, usually they print that out on the plastic itself. If you cannot find it, do not use that bottle. Also, there are other types of plastic bottles that you might encounter. For example, HDPE, high density polyethylene. This type of plastic has pretty good molding characteristics, and also it is chemical resistant. Some of the acidic beverages like orange juice, milk boxes, and also detergent bottles are usually made with this type of plastic. You can even buy HDPE filament spools directly. They are available for sale. But HDPE is pretty hard to 3D print. Mostly because it is pretty hard for it to stick to the printing bed. I encountered horrible warping issues like you see in this picture. I wasn't able to print HDPE commercial filaments and I gave up on it. So I didn't even try to make a filament out of it. However, if you know how to print it properly, I can optimize my process for HDPE. Because making filament from HDPE is even easier than the PET bottles. And also, it is fairly common type of plastic. Another questions were related to bottle preparation. Cleaning is one of the most important steps that can be forgotten. I realized every time I did not clean it properly, filament was getting broke. Also, it was especially the case for the oil bottles. Not only filament breaks off, it also smells like someone is making French fries. Also, most of the time there is a glue to stick the sticker. After removing the sticker, you need to clean that as well. But it is quite solid and hard to remove within the room temperatures. However, once you heat up the bottle, you can easily remove the glue, because glue melts quite easily if you put the bottle on the stove. You just need a paper towel or a cloth to remove it. In the previous video, I used alcohol to create pressure inside of the bottle, but I strongly recommend you to not use alcohol, because of the safety reasons. Since it is highly flammable and it is clearly creating a fire hazard with the alcohol vapor. You can use just water instead. It will just take a little bit longer. Once bottle starts to change shape, it is the right time to clean the glue. During that time, it will be as easy as removing the water out of the bottle. In this step, most important thing is removing all the molding features from it. Don't get too close to fire, and time to time give it a little shake. Don't rush this step. Unless you leave the bottle on the stove for a long time, it won't melt or burn. Consistency is the key here. For the oil bottles, there are two things that you need to be careful for. First of all, to clean them, I recommend you to use a kitchen grease cleaner. Without it, it is pretty hard to remove oil stains inside of the bottle. Then rinse it properly. Second important thing is about safety. Oil bottle caps are not designed for high pressures. So the bottle cap can open during this process because of the pressure. You need to push the cap all the time. It is also a good idea to wear a kitchen glove to protect your hands from the hot pressure, especially on the cap side of the bottle. For the all bottle types, turn the bottle in a way that it tightens up, because when there is a pressure, it is quite easy for cap to open when you are doing this step. Be careful when you are finished and ready to open the bottle, because there will be a hot steam released. Finished result will look like this, mostly uniform and ready for cutting. This step is identical for mineral water bottles and other type of bottles as well. You can make multiple of bottles in one go and save time in the future. Also, some people ask me how I find different color of PET bottles. Honestly, the trick is I do not find any colored PET bottles at all. I mostly use transparent bottles, and I have already made a separate video about how to make colorful filaments, so I will not get into detail. If you want to watch that video, click to the link on the corner and you can see it for yourself. Another questions were related to strip specs. I made a bottle cutter for making this step simpler. It consists of one blade and two spacers. For cola bottles, I use 5mm spacers, and for mineral water bottles, I use 7mm spacers. If you need, I also uploaded printable models as well. You can print those and use them instead if you don't have any metal spacers. Another question was related to the thicknesses of the bottle strips. Well, measuring these small thicknesses are not very accurate with this caliper, but here you go. For the cola bottles, it is around 0.2mm, and if you would like to use mineral water bottles, the thickness is around 0.15mm. And also, if you would like to check my favorite as well, the oil bottles. The strip from the oil bottles has the most thickest one, and it is around 0.3mm. I was able to get the most material from the oil bottles. Also, we are not getting any deposit for the oil bottles, so it is good for recycling as well. Another highly discussed topic was connecting straps to each other. For this step, I did quite a lot of trials, because you will soon realize that material from one bottle is usually not enough for one print. Usually, depending on the model, I use quite a lot of filaments. And that was the main reason that I made this project in the first place. So connecting the straps to one another was the most logical solution for this requirement. I tried soldering them to each other and tried connecting them in other ways, but the result was mostly the same. Every time I tried to join the straps, it broke off. During my experiments, I realized, especially if I used different bottle types for connecting, my failure rate was increasing significantly. For example, connecting cola bottles and mineral water bottles was not working at all. If you want to increase your success, I recommend using the same bottle type for one print and collect your bottle straps separately for different type of bottles. After many trial and error, I was able to manage it with one method, and I sticked following the same method every time. Here, as requested, I am going to demonstrate how I connect them to one another in a more detailed way. I cut the strip that I want to connect to another around 2 mm and make it thinner. This part is important, and I realized it after a long time. The strip that I cut will be the one that will be later fed to the 3D printer later on. And I mark 3 points on the strip with a permanent marker with 5 mm distances. After that, I drill 3 holes on the strip with a 2.5 mm driller bit on the marked locations. Then I connect them to one another as I show in this video. Bending the last bit is important because it helps two strips to be fused to each other. Otherwise, it breaks off very easily. And also remember, material should flow the whole strip to connected strip for better connection. Because I have seen that sometimes filament breaks off if it moves other way around. There is also another very different method that I described later on. Do you remember when I mentioned about how filament is shaped after this process? It is not entirely solid and it looks like a tube. I discovered that this property can be used to connect filaments to each other as well. To demonstrate it, I will use one of the scraps that I had lying around. First, you need to cut the filaments that you want to connect with a 45 degrees angle. I don't know if it can be seen in this video, but there is a tight gap inside of the filament cross section. Simply, you can slide one filament to another and make a bigger filament. And voila, you have a longer filament. And they hold pretty well. You need to apply a little bit force to separate them from each other. If you cut the filaments that you want to connect with a 45 degrees angle, 3D printer fits without an issue. I find this method useful when connecting scraps. This part is specific to Ender 3 stock printers. There were some remarks about the printing temperature for Ender 3. In the previous video, I set my temperature to 270 degrees Celsius. However, if you are using a stock Ender 3, you should not go above 240 degrees. Unless you are using an all-metal hot end. Then it won't be an issue. I am mentioning it in this video because if you increase the temperature to 270 degrees Celsius, the surface quality will be significantly better. You can print PET on 240 degrees Celsius without an issue, but printing quality will be like a regular PETG filament. If you increase the temperature a little bit, the surface will be really shiny and smooth. Here's a comparison. This one is printed with 240 degrees Celsius. If you look at the quality of the surface, it is alright, but you can see a little bit threads on the surface and it's not that shiny at all. And this orange duck, for example, printed with 270 degrees Celsius, and I love the surface quality. It's pretty smooth and shiny, and I think that's the best quality that I have achieved with this PET filament. Another example, the blue duck, also it's printed with 270 degrees and the surface quality is excellent, and there were no threads or whatsoever. So if you are alright with this print quality and don't want to modify your 3D printer, then go with the 240 degrees Celsius. But if you are right with investing to all metal hot end, then I really recommend you to go to the 270 degrees Celsius. But it's up to you, of course. There were many comments about the electronic setup of the filament maker. First, I will start with the last question. You can use any Arduino board that you like. I made the prototype on an Arduino Uno board and I uploaded the same code to Arduino Nano because it has a smaller form factor. Some people wondered about how I powered it up. As you can see, there are two cables. One of them is for 3D printer power supply and other one is for the filament maker. I used an old laptop charger like this one to power it up. There is a buck converter to reduce the voltage to 5 volts for Arduino. To hide cables and electronics, I put everything in an electric box. For buttons, I soldered two tactile buttons on an Pertinax board, but you can use a fancier buttons if you like. Since I don't use them often, I hang them like this. I left the MOSFET outside because it can get a little bit hot. I also attached an aluminum piece on it to increase the thermal flow. This simple setup was enough for MOSFET to operate properly. Some people ask me if they can use 3D printer's power supply. You can use 3D printer's power supply for sure. Easiest way is the disconnecting XT60 connector on the power supply and adding a Y splitter in between. I will put a link in the description if you want to connect your 3D printer's power supply to filament maker. As the last part of the video, I would like to mention about the GitHub page, because most of the answers related to your questions can be found here. Let's go to the circuit diagram, for example. I use an Arduino Uno for my prototype and I uploaded the same code to Arduino Nano. Since they are sharing the same microcontroller, the code works without an issue on an Arduino Nano board as well. So you can use whatever you have. I just wanted to have something more compact. And here you can see I connected two buttons to pin 8 and pin 9, and I connected LCD to analog pin 5 and analog pin 4, and this gray component is the temperature sensor, and I connected it to 3.3 volt output of the Arduino Uno board, and it is connected to the analog pin, and in the middle I have my resistor. The reason why I am connecting it to the 3.3 volt is because if you connect it to the 3.3 volt, the analog pin on Arduino board will provide you more sensitive information, and it is important in this setup. And if you go to here, you would see my MOSFETs, and the name of the MOSFET is IRLB8721, and it is pretty good for this application. And you see, first pin is going to be connected to pin 3, and last pin is going to be connected to the ground, and the middle pin is connected to your heater element. In here I used an LED to represent the thermistor. The reason why I use this LED is because the software that I used to draw this circuit diagram didn't have a thermistor, so don't get confused by it. And if I go to the code over here, I try to put some information in the code as well for ease of access, and you would see my set temperature variable. This is a temperature level that I set for the filament maker, and it is 253 Celsius. What I did was setting it to a roughly a value like 250 and increase it a little bit by the buttons, and after a while then I realized in 253 degrees Celsius it worked pretty well, and then after deciding the temperature level, uploaded this code to the Arduino, and from now on I rarely change the temperature settings on the filament maker. And other than that, the code is pretty straightforward, and I don't think that it will cause any issues for you. See you next time!